Hi guys. Now that you have finished actually testing your structure to protect a package from for Amazon Prime, now you need to complete part two of the assignment. So part one, remember, was the building and the testing of the structure, and now part two is really how do we apply what we've learned in this unit to that part. So you're going to go to the Primaire final project assignment, and in short terms, you need to complete this entire slideshow, right? This slideshow is going to ask you to apply Newton's laws and to find the force that your package hit the ground with, right? It's going to have you look at everything we've learned with regards to this project. But I will walk you through each part just so it's clear on what you need to do. So for the first slide, you're going to want to give this project a title, right? Be creative. Do something related to Amazon Prime Air or drones or egg drops, right? And then you're going to write your name, first and last, your period number, and cohort A or B. And then it's expected that you either have pictures of your project or even maybe a video of your project, but to add that to the front of your slideshow. Okay? All right. The first couple slides is the calendar again, so there's nothing you need to do. The first part has all the details about, actually building the structure, which you've already done. And so now it's really, really your responsibility from now till Thanksgiving break. And actually, one sec, I should have had this date ready. This assignment is due on November 19th. So that's a Thursday. So November 19th, your responsibility is to complete slides 11 and on. Okay? So slide 12 just gives you kind of a heads up of, how is this part of the project being graded? What do you all need in the project? And so for the most part, each slide is 5 to 10 points based on, what it's asking. Okay? And so really, if you just complete all the slides and make sure you don't delete any of the slides, then you should be good to go. So the first slide is all about your diagram and your design. And so you need to insert a diagram of your structure. You can either draw it or you can use Google Drawing. But with that diagram, it doesn't necessarily need to be a technical drawing, but it's still important that's a high quality diagram so that it has, labels on what are some of the materials that you used, and it has dimensions written down, right? It might not be to scale, but showing that, the length and width of your structure was so many centimeters. Okay. And then to get to really, challenge yourself to get an A, right? I think A as an advanced. To be advanced, you need to have at least two views of your structure. So a side view and a top view. Okay. And again, you're going to add that in the box. And the specifications is your length, the mass, the acceleration, it moves down, right? You can just use the acceleration of gravity, right? Gravity pulled down every structure. And then for force of collision, that's something you're going to have to calculate using Newton's second law. So F equals mass times acceleration. So if you have the mass of your package, remember this needs to be in kilograms, and the acceleration of gravity, then you're just going to multiply those two numbers together to find the force of collision that that package hit the ground with. Okay? Then the last thing you're going to calculate is the speed of that package. And so during the egg drop, you should measure the distance of the height of the fall. If you're at home and you're testing, that might be something you have to estimate, which is fine. but still make sure there is a number in there. That should be in meters. Time of fall, right? You either videoed it or hopefully used a stopwatch to see how long it took to fall that height or that distance, and then you'll use both of those numbers to find the speed of your package. Okay, so that's the first slide. Then the second slide is all about what materials did you use? Why did you use those materials? And why do you think, why did you decide to use the design that you did? Right? So if you decided to put a parachute or you decided to put springs or whatever the case, right? You're going to talk about why you wanted to use a parachute, why you wanted to use springs. And again, to get advanced on this page, I'm looking for scientific vocabulary, right? If you used a parachute, talk about air resistance, talk about balanced and unbalanced forces, talk about the net force, right? How does parachutes impact the force? If you decided to use like springs or something else, right? Maybe apply it to Newton's laws. But you're justifying the why you used the design that you did. So that's that second box, okay? Then the next page is all about evaluating your structure. So you're gonna have to, let me know, right, how much damage was done to your egg, and you'll just highlight the box that fits the damage done to your egg. And then you're going to be kind of identifying and thinking about what were the flaws or weaknesses of your designs? What were areas that you can improve on? And then the second box is really thinking about those flaws and weaknesses and how would you change it if we did this again? What changes or improvements would you make related to the flaws that you observed? Okay, definitely don't write like there are no flaws. Like even if you were successful and your egg was protected, right? You could start thinking about, were there certain materials that you could have changed to make more eco-friendly? Or were there ways you could have made it less massive, right? So then the drone could conserve more energy. Or even thinking about, is it possible that you could save more than one egg? How would you do that? Okay, maybe the flaw of your design is that it only saves one egg. Okay, all right. And then page 16, you are creating potential and kinetic pie charts for each position that the egg or the package is in. And so you'll just create a pie chart. You can do Google Drawing. You could actually create a pie chart using Google Sheets, but you'll show, how much potential and kinetic energy percentage-wise does the package have when it's held by the drone? How much does it have when it's free falling and kind of like mid fall? And then how much does it have right before it hits the ground? Okay. Then you also are going to create free body diagrams for your package at each point. In order to get advanced on your free body diagrams, I want you to include special elements of your design that's going to impact your forces. So for instance, if you have a parachute, right, and the parachute is used to slow down maybe how fast the package is going, you need to also include what forces are acting on that parachute. Is there air resistance? Is there gravity? Is there some applied force? Like what forces are acting on the parachute? If your package has wings, maybe looking at the wings, but making sure you are including special elements of your design that are being acted upon by forces. Okay, and then the last one is just determining like, is the forces on this package balanced or unbalanced, and how do you know? And so you'll type those into that last box. Okay. Then for slide 17, it's all about applying Newton's 3 laws of motion to our project. So each one asks you, what is this law stating? What is this law? And then asking you a couple questions that relates that law to our package. Okay. And then slide 18 is some reflection questions. And all I ask that you do is that you answer these questions in complete sentences and you're thoughtful about it, right? And you use periods and capital letters. Um, and again, be thoughtful in this reflection because these are kind of some questions that really help you think through this process, right? And when you're given another STEM challenge, what are things you want to keep in mind? And then in order to score advance, in the reflection part, there are a couple extension questions where it kind of extends your thinking and thinking about, if this package was being dropped somewhere else, not on Earth, but where there might be less gravity, how would that differ? Or thinking about, if Newton's laws weren't in effect, right? Newton's laws aren't true, and so thinking about, how might that affect the package being dropped? So really kind of extending your thinking. Okay. Anyway, this slideshow is part 2 of your egg drop project, right? And there will be a self-assessment. It's like a checklist that you will be completing next week just to make sure that you have included all of the information that's asked of you and also making sure to check your work and um, ensure your calculations make sense and that you use complete sentences on your reflection and so forth. Okay. If you do have any questions about this part, make sure you reach out. And then again, this is going to be due on Thursday, November 19th. So you can start this project this week. And then you'll also have next week during your remote lesson to finish it. Okay. All right. Have a good day. Bye, guys.